Okay, let's unpack this. In the, fast-paced world of data, if you're looking for a shortcut to understand where things are really heading, there are three names that keep popping up, not just trending, but genuinely shaping the future. We're talking Postgres, OpenTelemetry, or OTel and Iceberg. But like, why these three specifically? Why are they winning in such a crowded market? And what makes them the new sort of gold standard for data pros like you?
Yeah, it's fascinating because while Postgres is, a familiar name, rock solid, OTel and Iceberg might be newer to some folks, but they all share this common, really powerful DNA. And our mission today in this deep dive is to kind of pull back the curtain, understand that shared DNA, and explain why these principles behind them are so compelling. For anyone building, managing, or analyzing data, these are crucial shifts impacting developers, SREs, data scientists, everyone, really.
Exactly. We've gone through the latest insights, the recent analysis, and what we found offers, well, basically a front row seat to these critical shifts happening right now. Think of this as your guide to making sense of it all. So let's kick things off with maybe the most fundamental question. Why did Postgres win so decisively? You often hear extensibility as the answer.
Well, now that's true.
And it absolutely is true. It's incredibly powerful. But the analysis we've looked at, it reveals a deeper layer, a deeper understanding of what open sourceness truly means. And it's this that actually drives its widespread, almost, inevitable adoption. It kind of boils down to what we're calling the three tenets of open source.
That's right. When developers look at an open source project,
Mhm.
they're maybe intuitively checking it against these core ideas. First one, the license. Super important. It absolutely must be OSI approved. So a recognized, genuinely open, independent standard, not tied to some single company's agenda. Think the PostgreSQL license. It's incredibly permissive, developer-friendly, kind of like MIT.
Yeah.
Then the second tenet is self-hosting. The entire product, the whole thing, needs to be genuinely feasible to download, install, run yourself. And this isn't just, the code's on GitHub. It's about the practical ability to actually control your own destiny with it. No hidden hooks, no proprietary bits you suddenly need.
Okay, and here's where it gets really interesting. This third one, often overlooked, it's all about commercialization. Is the project, commercially unencumbered, truly vendor neutral, or even better, is it backed by lots of different commercial companies?
Right.
Which makes it basically impossible for any one company to dominate its direction. Our research had this great analogy. Think of Postgres, like the International Space Station.
Huh.
Yeah. Several huge entities collaborate because no single one can own it. This multi-entity backing plus strong governance, it creates this powerful cultural resistance. No single vendor can take over.
And that raises a really important point for you, the listener. Why does this matter so much? This multi-entity backing, this commercial neutrality. Why is it crucial? Well, it means the tech isn't tied to the fate or the strategy shifts or, the potential acquisition of just one vendor.
Yeah, that's huge.
It fosters this deep level of trust and long-term stability. If you're building on it, you have confidence your investment in the tech won't suddenly get yanked out from under you by some company changing its mind, or worse, its license.
Right.
It's really the foundation for a truly open, sustainable ecosystem.
So nobody's going to pull a surprise. We bought your database and now everything changes. Move on you. That definitely builds confidence. Fewer sleepless nights for developers, I bet.
Exactly.
So Postgres nails that open source test. Checks all the boxes. But here's the thing. It's not a magic bullet for all data tasks, is it?
No, definitely not.
Different jobs, different teams, they need different tools. And to get our heads around this, the analysis we looked at highlights three main data personas and the kinds of tools they typically use for working with information.
Precisely. We can kind of break down the main ways people interact with data into these three groups. First up, OLTP databases, online transaction processing. Think like the database behind your banking app or an e-commerce checkout.
Okay.
These are mostly used by developers building the actual applications, handling those split-second transactions where speed and absolute consistency are just non-negotiable. Second, there's telemetry. This is the world of SREs, site reliability engineers, the folks keeping the lights on.
Guardians of the system.
Right. Their focus is monitoring system health, optimizing how apps perform, collecting logs, metrics, traces, getting those real-time insights into what's actually happening under the hood. And finally, OLAP warehousing, online analytical processing. This is more the domain of data engineers and data scientists.
The insight hunter.
Exactly. Their job is to analyze huge historical data sets, look for patterns, insights, stuff that supports business intelligence, critical decisions.
Okay, so traditionally, the data lifecycle kind of flowed in that order, right? Build the app, OLTP, add monitoring, telemetry. Then eventually, as you scale, you need a warehouse, OLAP.
Yeah, that was the typical path. 1, 2, 3.
But we're seeing this interesting shift-left trend happening now.
We are.
As the tools get better, easier to use, things like observability and warehousing, they're increasingly becoming something developers handle themselves earlier on.
That's right.
And it's not because SREs or data engineers are, like, stepping back.
No, not at all.
It's more that the databases themselves are getting so much more scalable, more user-friendly, that developers, especially at startups, can manage way more of the data lifecycle before needing, specialized teams.
It's empowering for them, definitely. More control earlier.
And this is where those three names we started with, Postgres, OTel, Iceberg, really come together. Around these core data use cases, these personas, our research highlights these three emerging open data standards. And crucially, they all exhibit those strong open source tenets we talked about earlier.
That's the connection, exactly.
Okay.
For OLTP, online transaction processing, the standard is, well, it's Postgres. Pretty undeniable now.
Right.
For telemetry, it's OpenTelemetry, OTel. And for OLP, the warehousing analytical side, the emerging standard is Iceberg.
Okay. But it's important to make a distinction here, isn't it? OTel and Iceberg especially. They're more like standards than just tools.
That's a critical point, yes.
Can you unpack that a bit, maybe an analogy?
Sure. Think of HTML. HTML is the standard for web pages. Right?
Okay, yeah.
Chrome, Firefox, Safari. Those are the tools, the browsers, that adopt and render that standard. It's similar here. The data itself, whether stored or in transit, follows an agreed-upon format defined by the standard, like OTel or Iceberg. Any tool wanting to play in that space has to adopt the standard or risk getting left behind.
And that's huge for users, for you listening.
Absolutely.
It means you're not locked into one vendor's little walled garden anymore. It forces companies to actually compete on making better products, better user experience.
Exactly. Not just on lock-in. It creates a healthier market. So let's dive a bit deeper into each one. Postgres. As you said, it's kind of both a tool and it's fundamentally become the open OLTP standard.
Right.
You see almost every new database aiming for Postgres wire compatibility, meaning other tools can talk to it as if it were Postgres. Huge for interoperability. And because no single company owns it, every major cloud provider offers it as a service if you have a bad experience with one vendor. Well, portability is surprisingly easy.
Yeah.
You can literally just use pgdump, grab your data, and move somewhere else.
Wow. That's real openness.
It really underscores that openness. Plus, that very permissive PostgreSQL license backs it all up. Okay, next, OpenTelemetry, OTel. It really lives up to its name, open. Now, it is still relatively new, and gotta admit, it can be quite complex to get started with.
No, I've heard that before.
But it absolutely fits those open source tenets. Apache 2.0 license, totally vendor neutral. And just like the cloud providers embrace Postgres, the big players in telemetry, Datadog, Honeycomb, Grafana Labs, Elastic, they're all adopting OTel now. They kind of have to.
Right.
And if you prefer self-hosting, there are great open source options too, like Signaz or OpenObserve. Gives you complete control.
Okay, you mentioned OTel is nascent and admittedly quite complex. So for a developer maybe new to observability, what's like one immediate tangible win? Why embrace it now despite that complexity?
Yeah, good question. I'd say the immediate win is future-proofing. Simple as that. By using OTel from the start, you're collecting your telemetry data, your logs, metrics, traces in a universal language. So down the road, if you want to switch your backend analysis tool, or maybe even send data to multiple tools simultaneously, you can do that without rewriting all your instrumentation code in your applications.
Ah, right. Avoids that massive rewrite pain later.
Exactly. Give you incredible flexibility and avoids that vendor lock-in right from day one. Okay, and finally, Iceberg. This has really emerged as the leading open OLAP standard. These open table formats, like Iceberg. They essentially provide a standard blueprint, a way to organize, index, and version control massive data sets, petabyte scale, easily.
So like a universal file cabinet for huge amounts of data.
Kinda, yeah, but smarter. I mean, any tool that understands Iceberg can read and write that data reliably. Think about swapping out your entire analytics engine, maybe going from Spark to Flink or something else, without having to copy or reformat petabytes of data first. That's the power.
That's huge.
It is. And while there are competitors, Delta Lake, Hootie Iceberg seems to have really pulled ahead. Adoption's widespread. Databricks, Snowflake, ClickHouse, they all support it. And what's really significant, tying back to that third tenet, that commercial neutrality, is the role AWS is playing. They announced S3 tables late last year, which basically makes it trivial to store data directly in S3 using the Iceberg format.
Ah, so AWS is putting its weight behind it too.
Big time. That really helps cement it as a foundational standard for big data analytics.
Okay, so we've got these powerful open standards, Postgres, OTel, Iceberg. But what's the underlying, the foundation? What makes all this possible at scale? The analysis we reviewed points very clearly to object storage, specifically S3. It's rapidly becoming the fundamental substrate, the bedrock for all three.
Absolutely right. Object storage, S3 especially, is just incredibly cheap, dirt cheap, relatively speaking. And that makes it the ideal foundation for all this modern data tooling. We're seeing a really strong trend, pretty much all new data tools being built. They're adopting some kind of interoperability with S3 or S3 compatible services. It's almost table stakes now.
Right.
And this whole movement is just getting faster. AWS keeps improving S3, things like conditional writes, making it safer to use concurrently.
Yeah.
And S3 Express, which is what, 10 times faster than standard S3.
Yeah, and they slashed the price recently too.
Exactly, 85% cheaper now. So incredibly fast, incredibly cheap object storage. It's really accelerating this whole idea of S3 as a database.
What's fascinating, though, is how that S3 interoperability actually looks different, depending on whether you're doing OLTP, telemetry, or warehousing. It's not just one approach fits all.
No, very true. It adapts to the needs.
Mm-hmm.
So for OLTP databases, performance is king, right? Absolute top priority.
Milliseconds matter.
Totally. So you're always going to need a disk layer. Fast NVMe SSDs, usually attached right to the database server. You just can't get that speed over the network from S3 for those core operational transactions.
Makes sense.
So here, S3 comes into play mostly via things like zero ETL solutions or tiered storage, which basically means easy ways to move your cold data stuff you don't access often from the expensive database disks out to cheaper, scalable S3 storage without needing complex, slow ETL jobs.
Okay, so offloading the old stuff.
Right. And interestingly, you could even connect Postgres now to read Iceberg data stored elsewhere, like S3, using things called foreign data wrappers. Clever stuff. Now, shift gears to telemetry and warehousing. Here, the big challenge isn't usually raw transaction speed, it's cardinality.
Cardinality meaning?
Meaning the sheer volume and, crucially, the variety of data points you're collecting. Think millions of different metric names or log messages from thousands of services, way more complex than simple transactions.
Got it. More dimensions.
Exactly. And because S3 is getting so cheap, businesses are just storing exponentially more of this data. Why not?
If it's cheap, keep it all.
Right. And this shift fundamentally drives an architecture where storage and compute are completely decoupled, separated.
Okay, so you scale storage independently from processing power.
Precisely. Huge flexibility, huge cost savings potential. And that, in turn, has sparked massive demand for a new breed of compute layers. Often these are specialized embedded databases, like DuckDB for analytics, that can connect directly to your data sitting in S3.
So the compute goes to the data rather than moving data to the compute.
Pretty much. These tools can run complex queries right on the data in S3.
Wow.
Super efficient.
Okay, so bringing it all together, what does this actually mean for you, the listener?
Well, it points towards a future where your valuable data isn't going to be locked into one specific vendor, one proprietary system anymore.
Yeah. Freedom. It means that these open standards, Postgres, OTel, Iceberg, all built on the scalable, affordable, and increasingly fast infrastructure like S3. They're creating this ecosystem where companies genuinely have to compete on experience, on innovation, on the value they provide, not just relying on locking you in. And that's just a massive win for your flexibility and your control over your own data.
Yeah, and if we connect this to the bigger picture, it really suggests this powerful and accelerating shift happening in the data world, a shift that prioritizes open access, portability, flexibility above almost everything else. And that, I think, raises a really important question for you to think about. How will this increasing portability, this openness of data standards, how will it change the way you approach your next project? Or maybe even rethink your entire data strategy, knowing you've got more control and fewer barriers than ever before. Something to chew on.